So what is drifting? Drifting, in short, is the art of controlling an out-of-control car. It's the opposite of grip driving, which is normally taking a corner without sliding or losing any traction of the wheel. When drifting, the driver typically tries to lose all traction of the tires in the rear while maintaining traction and contact with the road of the tires in the front. This means that drivers often use rear-wheel drive cars with the engine in the front of the car, as opposed to all-wheel drive cars or front-wheel drive cars, or cars that have the engine in the middle or the rear. What you're seeing now is an example of drifting. The car's rear tires spin uncontrollably, causing lots of smoke to come out of the rear of the car, while the front tires remain in traction with the road, allowing the driver to keep control of the car and steer around the corners. The first physics concept seen in drifting is the concept of friction and coefficients of friction. As mentioned earlier, the object of drifting is to get the rear tires to lose traction with the road. When the tire is in contact with the pavement, there is friction between the rubber of the tire and the pavement on the ground. When the tire is gripped up to the pavement and not spinning uncontrollably, like seen in this picture, that means that there is lots of friction between the tire and the pavement it's on. For example, Formula One cars like this one use tires with a very high coefficient of friction so that the tires stay in contact with the ground and do not spin. This is similar yet different to how a drift car would utilize tires. Similarly, drift cars utilize sticky front tires with a high coefficient of friction in the front so that the front of the car stays gripped up to the ground and does not lose traction or spin uncontrollably. However, drift teams often utilize tires with a lower coefficient of friction in the rear of the car so that the rear wheels are more apt to spin and lose traction with the ground. This loss of traction allows the rear wheels to spin uncontrollably like seen in the picture. The next physics concept seen in drifting is the Doppler effect. The Doppler effect is a phenomena that explains why an observer will experience and hear higher pitched sounds as a sound source approaches them and lower pitched sounds as the sound source goes away from them. Here it is in slow-mo to hear it a little bit better. Here is a better example from a Formula One race. As seen in both of those clips, as the car approaches the observer, there is a higher pitched noise, and as it passes and goes away from the observer, the noise goes down to a lower pitch. As seen in the upper right of this picture, the frequency observed can be calculated using the frequency of the source, the speed of the source, and the speed of sound. The final physics concept we'll be looking at is torque. Torque is a measure of how much a force acting on an object causes that object to rotate. On a car, the wheels rotate around an axis. Torque is the cross product between the distance from the pivot point to the point where the force is applied and the force vector. The diagram shown here shows how force is transferred from the engine to the gears to the differential to the rear wheel, where the rear wheel then spins, creating rotational force, otherwise known as torque. This video shows how the rear wheels on the car are spinning while still in contact with the ground. The force of friction between the tires and the pavement is what prevents them from spinning. Once there is enough torque or rotational force applied to the wheels, that will overcome the force of friction between the tires and the pavement, thus causing the wheels to spin uncontrollably. When the tires begin to spin, the rubber of the tire begins to burn, which causes the smoke to come off the tires and into the air.